Uh, Good morning, students. Today, let us go for the chapter Solutions. Solutions. Okay, what is a solution? Let us answer this question. What is a solution? A solution is a mixture of a homogeneous mixture of a solution is a homogeneous mixture of two or more components. Two or more components. So this is the definition of a solution. And here, let us take some examples of solutions. Sugar, water. Sugar solution. Sugar. So this is one of the examples of a solution. Here I have taken two components. One is sugar component, one is water component. Let us take another example. Alcohol, water. This is alcoholic solution. Alcoholic solution. These are the some of the examples for solutions. Okay, benzene toluene. Benzene toluene. So, in all these examples, I have taken only two components. Therefore, such solutions are called binary solutions. Binary solutions. A solution which contains only two components. Such solutions come under the heading binary solutions. Okay? And also, you observe one difference here. For the first example and second example, the difference is, in the first example, this is solid and this is liquid. That was solvent. Okay? In terms of, let us take this as solute and this as solvent. So in the first example, one is solute and one is solvent, and solute here is solid and solvent here is liquid. Coming to the example number 2, here this is solute and this is solvent. Okay, but here both solute as well as the solvent, both are liquid solid. So it is a liquid solution. This is a solid liquid solution, and this is also liquid solutions. So this is briefly about the different examples for a solution. Okay, a solution mainly consists of a solute and a solvent. A solute and a solvent, and this solute may be either solid or liquid, or sometimes gas also, even gas also. For example, if you take ammonia solution if you take, you have ammonia gas present in water. So this is an ammonia solution. Here a gas is combined with liquid. So this is the, so a solution mainly consists of two components. One is a solute component, one is a solvent component. This solute component is usually either solid or liquid or gas also. But the solvent portions are usually liquids. Okay. So this is a brief about the what is a solution and what are the examples of solutions. Relatively, the component which is present in less amounts in a solution is called a solute. Is called a solute. So, for example, again, if you take a sugar solution, we know that there is little amount of sugar and more amount of water. So, the component which is present in less amounts is usually called solute. Okay. Similarly, the component which is present in more quantities or large quantity in more quantity is known as solvent. So in this example, sugar is a solute and water is a solvent. So that also you remember. So let me tell you here, I am considering only binary solutions. Only binary solutions means it contains only two components. Out of two components, one is the solute and another is the solvent. Solute is present usually in less amounts and solvent is present in more amounts. Okay. In different examples, this solute may be solid, this solute may be liquid, this solute may be gas also. This solvent is usually liquid. Usually the solvent is liquid. Okay. So the solute may be solid, the solute may be liquid, the solute may be gas. I have given the examples. For solid liquid sugar solution, for liquid alcohol water, for gas and liquid ammonia solution. And please also remember that the solvent may be, generally it may be liquid. Sometimes it may be gas also. Sometimes it may be gas also. Sometimes it is solid also. Okay. There are solutions in which both solute and solvent are present in the solid states. There are some examples in which the solute and solvents are liquid and liquids. There are some solutions in which both solute and solvent are in gaseous state. You take mixture of gas. For example, mixture of nitrogen and mixture of oxygen. Here one will act as a solute and another will act as a solvent. In this example, in this mixture of gases, okay, there are two components. Out of two, one will act as a solute and one will act as a solvent. Here you can see both are gases. So there is a gaseous solute dissolved in gaseous solvent. So this is a brief about the introduction to our solutions. Next, we shall go for ideal solutions. What are ideal solutions? Ideal solutions are those which obey Raoult's law. Which obey Raoult's law. So this is one of the conditions to be an ideal solution. Yes, solution is said to be an ideal solution if it obeys Raoult's law. It obeys Raoult's law. Okay. So now we shall go for the what is Raoult's law. This is one of the conditions. The other condition is that change in volume mixing should be 0. This is one more condition to be an ideal solution. Delta V mixing is equal to 0. This is the second condition for an ideal solution. Third condition, the enthalpy change on mixing should be equal to 0. So these are the three conditions required for an ideal solution. These are called thermodynamic properties. Thermodynamic properties of the ideal solutions. Thermodynamic properties. Okay. And usually the entropy change of the mixing is usually greater than 0. So this is one more condition for an ideal solution. So it should obey Raoult's law. The change in volume upon mixing should be equal to 0. The change in enthalpy upon mixing should be also equal to 0. These are the important conditions for an ideal solution. Okay. And if you consider another thermodynamic property, the entropy change after mixing is usually greater than 0. So these three are the thermodynamic properties of solutions. Thermodynamic properties of solutions. Now I shall tell you what is Raoult's law. What is Raoult's law? So before going to Raoult's law, the concentration of any solution, can be expressed either in terms of molarity, mole fraction, and so on. So these are the important terms by which the concentration of a solution can be expressed. And let us not worry about molarity and molality. In this class, let me tell you what I mean by mole fraction. So that I will tell you. Suppose if a solution contains two components, namely A and B. So this is component A and component B. In our solution, we have two components, A and B. Now, if Na is the number of moles of A, let us assume Na is the number of moles of A and Nb is the number of moles of B. Now, let me tell you what is mole fraction. Mole fraction is generally represented by the symbol X, and I am taking the mole fraction of component A. Mole fraction of component A is always equal to number of moles of component A divided by number of moles of component A plus number of moles of component B. Because in this solution we have only two components, A and B. Okay. Suppose if the same solution contains three components A and B and C, let us assume A and B and C, then the mole fraction of component A is equal to number of moles of A divided by number of moles of A plus number of moles of B plus number of moles of C, component C. So like this, you have to calculate the mole fraction of the solute. Any components, mole fraction of the any components which is present in the solution. Okay. It is the mole fraction of component B is equal to NB, number of moles of component B plus number of moles of component A plus number of moles of component B. This is the formula for the mole fraction of B, component B. So you remember these things, and these things are useful for the further studies of solutions. This is a brief about the mole fraction, and mole fraction is one of the term which is used to express the concentration of the solution. Okay. Now we shall come for Raoult's law. What is Raoult's law? What it tells means the partial vapor pressure, of a solution is equal to mole fraction of that component is equal to the product of mole fraction of that component and the exact vapor pressure of that component. The partial vapor pressure of, let me tell you here, a component is equal to the product of mole fraction of that component and the exact vapor pressure of that component. Say for example, if the solution contains two components A and B, in the last example I told you, if the solution contains two components A and B, then according to Raoult's law, the partial vapor pressure of A, this symbol stands for partial vapor pressure of A, or you can write here simply PA, partial vapor pressure of A is equal to the mole fraction of this component into exact vapor pressure of the component of the actual, and the actual vapor pressure of that component, P on A. So this is the partial vapor pressure of a component is equal to mole fraction of this component into actual vapor pressure of that component. Here this is the partial vapor pressure, this is the actual vapor pressure. Okay. Similarly, for this component, the partial vapor pressure of B is equal to mole fraction of B into actual vapor pressure of the component B. So this is the Raoult's law. This is the definition of the Raoult's law. The partial vapor pressure of any component present in the solution is equal to its mole fraction multiplied by its actual vapor pressure. This is the definition of Raoult's law. Let me say it once again. The partial vapor pressure of any component present in the solution is equal to its mole fraction multiplied by its actual vector function. Its actual vector function. So this is about the process. Okay, and an ideal solution, as we told you already, an ideal solution should obey Raoult's law. It should obey Raoult's law. Okay, on first condition. Number 2, the delta V mixing, the change in volume after mixing should be equal to 0. So what do you mean by mixing? Here, if I to get the solution, I am mixing component A with component B. In this mixing, okay, the change in volume should be always equal to 0. Then the change in enthalpy after mixing also equal to 0. So it should obey Raoult's law. The change in volume upon mixing should be equal to 0. The change in enthalpy upon mixing is equal to 0. If a solution satisfies these 3 questions, then that solution is called ideal solution. Ideal solutions. Okay. Any solution which do not obey these conditions is called a non-ideal solutions. Non-ideal solutions. Or real solutions. Real solutions. What is a real solution? A real solution is one which do not obey Raoult's law and which do not satisfy the following conditions. Such solutions are called real solutions or non-ideal solutions. So in the next class, I shall go in detail about the ideal solutions. Then I shall go for the non-ideal solutions in the next class. Okay? Thank you.